Synthesis of an anti-inflammatory drug using upcycled PSSA. In this video, I'll be using the upcycled PSSA catalyst, which we made from waste polystyrene pipettes, to synthesize an anti-inflammatory drug. I started off by weighing out around 25 milligrams of my PSSA catalyst. I then weighed out around 76 milligrams of 4-nitrobenzaldehyde. I then carefully added both of these to a pressure tube mounted above a heating block on top of a hot plate set to 80 degrees. Finally, I use a pipette to carefully measure out and add 0.5 milliliters of 2-methylfuran to the tube. I then sealed the tube and placed it into the heating block and turned on the stirring. The progress of the reaction was monitored using thin layer chromatography with a 19:1 ratio of hexane and ethyl acetate. The lower spots are the 4-nitrobenzaldehyde that we started with, while the higher spots are the product formed during the reaction. The reaction is complete when the 4-nitrobenzaldehyde spot disappears from the final column. After the reaction was complete, I dissolved the product in ethyl acetate and I emptied the tube into a 100 milliliter round bottom flask. I then rinsed out the tube multiple times with ethyl acetate and I evaporated away the solvent using rotary evaporation. To prepare the product for column chromatography, I first dissolved it in a small volume of dichloromethane, and then I added a small amount of silica. I then evaporated away the dichloromethane using rotary evaporation, leaving me with a thin powder on the sides of the flask, which I was able to scratch off and add to the column. I then collected the fractions, once again using a 19:1 mixture of hexane and ethyl acetate. I then used thin layer chromatography to determine which of the fractions contained my product. Once again, the higher spots were my product, while the lower spots were residual 4-nitrobenzaldehyde. I then combined the fractions containing my product into a 250 milliliter round bottom flask, and I evaporated away the solvent using rotary evaporation. After all of the solvent had evaporated off, I clamped the flask onto a stand, and I left it to sit for an hour. As the flask cooled down to room temperature, crystals began to slowly form on the sides of the flask. This was the anti-inflammatory drug product. I then used a metal spatula to scratch these crystals off of the side of the flask, and I carefully collected the product in a sample vial. The final product obtained is a bright yellow solid, an anti-inflammatory drug which we synthesized using a catalyst made from waste polystyrene labware.